2. All right, we already know the rules, 1.5 hour. All right, because we're working through it a little bit slow, of course, we'll be going a little bit over that, but let's get to this paper. So, question 1, it says a quadratic equation is given by ax squared plus bx plus c, and it says that the roots of the quadratic equation are alpha, which is 1 minus 3i, and beta. Calculate what is alpha plus beta. Now, we know how to do this. Once they give us alpha is 1 minus 3i, then beta is going to be 1 plus 3i, because we know that complex roots, they occur in conjugate pairs. So we can say alpha plus beta is going to be equal to 1 minus 3i, that's for alpha, and we know what beta is. It's going to be plus, beta is 1 plus 3i. All right, so we work out what is 1 minus 3i plus 1 plus 3i. That will give us alpha plus beta. 1 plus 1 is 2, and then minus 3i plus 3i is 2. So that's alpha plus beta. So alpha plus beta is 2. That's how you get alpha plus beta. The next thing we're going to want to know is what is alpha times beta. Now, alpha times beta is going to be 1 plus 3i times 1 minus 3i. But that's just the difference of 2 squared. 1 minus 3i times 1 plus 3i. Given that we know that this is the difference of 2 squared, we know that it's going to be first term squared minus second term squared. So it's going to be 1 squared minus 3i all squared. And then we know what 3i all squared is. 3i all squared is 9i squared, and minus 3 squared is 9, I squared is minus 1, so it's 1 minus 9, so that becomes 10. So that's alpha beta. Nice and easy, soft. That's 10. That's the value of alpha beta. So this question is finished. It just wanted alpha plus beta and alpha beta. Nice. So that's 3 marks. Let's look at the next part of the question. The next part of the question says, hence, show that the equation with roots 1 over alpha minus 2 and 1 over beta minus 2 is given by this. Now, one thing we do know is that the equation of a quadratic is given by x squared minus the sum of the roots times x plus the product of their roots, and that is equal to 0. That's how we find the equation of a quadratic. All right, now we need to find what is s. S is going to be equal to 1 over alpha minus 2 plus 1 over beta minus 2. That's how we find the sum. Not plus 1 over alpha minus 2 plus 1 over beta minus 2. So in order to add them, we're going to have to use the LCM. So find their LCM. The LCM of alpha minus 2 times beta minus 2. That's going to be the LCM. Alpha minus 2 times beta minus 2. And then we go alpha minus 2 into this denominator leaves beta minus 2. And then beta minus 2 into this denominator leaves alpha minus 2. And so this works out to be, in the numerator, it's going to work out to be alpha plus beta minus 4. So it's alpha plus beta minus 4, that's the numerator. Alpha plus beta minus 4 over, in the denominator, it's going to work out to be alpha beta minus 2 alpha minus 2 beta minus 4. So in the denominator, it's going to work out to be alpha beta minus 2 alpha minus 2 beta. This is just the denominator, minus 2 alpha minus 2 beta plus 4. And know what, I shouldn't have squinged it right here, but let's go ahead and evaluate. Alpha plus beta we found is 2, so that's 2 minus 4 over alpha beta is 10, and then minus 2 alpha minus 2 beta is really minus 2 times alpha plus beta, and alpha plus beta is 2 plus 4. So we work this out, and that will give us the sum. So let's put down the sum somewhere up here in black. So the sum is up here in black. It is 2 minus 4. 2 minus 4 is negative 2. It's negative 2 over 10 minus 2 times 2 plus 4. That's 10. So the sum is minus 2 over 10. That's the sum. Now let's find the product of the two roots now. Now their product P is going to be equal to 1 over alpha minus 2 times 1 over beta minus 2. So 1 over alpha minus 2, and it is multiplied by 1 over beta minus 2. When I multiply these two, what am I going to get? When I multiply them, I'm just going to get 1 over alpha times beta is alpha beta. So it's alpha beta minus 2 into alpha plus beta plus 4. That's what I get when I work out the denominator. And so the product works out to be 1 over 10. That works out to be 1 over 10. So now that the product is 1 over 10, what does that mean? So getting that the product is 1 over 10, and so now I can find the new quadratic equation. The new quadratic equation is going to be x squared minus the sum, and it's going to be minus the sum becomes plus 2 over 10 times x plus the product, which is plus 1 over 10, and that's equal to 0. So all I have to do now is multiply through by 10. So multiply through this equation by 10, and that will give me x squared. That will give me x squared plus multiply through by 10, I get 10x squared plus 2x plus 1 is equal to 0. And that's how we prove this question. Nice and easy, soft. That takes care of the first part. Now, part B. Part B says the complex numbers are given by u is equal to 4 plus 2i and v is equal to 1 plus 2 times the square root of 2i. And this complete the Argand diagram to illustrate u. So to illustrate u is just going to be on the real axis it's 4. So we go 4, and on the imaginary axis we go positive 2. And say u is this point right here. And so just going to draw a straight line from there. So drawing a straight line from the origin to here, that represents U. So this represents U. Nice and easy. So, all right. Now it says on the same Argand diagram, sketch the circle with equation z minus u equals 3. If we're sketching this circle, the first thing I want to know is where is the circle? Z minus u is z minus 4 plus 2i. So this is what we're sketching, and that is equal to 3. So that means that the radius of the circle is 3. So I'm going to go 3 units across to 7. So I know that, and I'm going to go 3 units below, which is 2. I know the circle going to go through minus 1 here. 3 units across, going to go at 1. And 3 units above 2 is 5. And so then that's the circle passing through these points there. So let's draw the circle now. Let me see. This can work. Not quite. All right, that's it. All right, so just wanted to make sure that the radius is 3. Make sure the radius is 3. Yeah, that should be fine. All right. So we made sure the radius, we can show them that this radius is 3. So this will be the circle that will be z minus u, and that's equal to 3. That's the locus. The locus is a circle with a radius 3, with the center being 4, 2, which is u. All right, so that's what we have. Nice and easy, soft. The next part says calculate the modulus and principal acute argument of z, which is u over v to the 5th power. So first thing, before you work out what is u over v to the 5th power, once you see u over v, this is not in standard form. So we're going to need to rationalize by multiplying by the conjugate of v. Remember, u is 4 plus 2i. Not sure what was v was again. Let's check what was v again. So going back, v is 1 plus 2 root 2i. So v is 1 plus 2 root 2i. So we're going to multiply by the conjugate of the denominator. Multiplying by the conjugate of the denominator is 1 minus 2 root 2i. And so we're multiplying also the denominator by 1 minus 2 root 2i. And that will give us u over v. So let's work it out now. Multiplying them across, 4 times 1 is 4. 4 times minus 2 is minus 8 root 2. That's minus 8 root 2i. Then we have 2i times 1 is 2i. And then we're going to have 2i times minus 2 root 2i. But 2 times 2 is 2 times 2, that's going to be 4. That's going to be minus 4 root 2i. And then I times I is I squared, so it's minus 4 root 2 I squared. And that's divided by, we have the difference of 2 squared, which is 1 squared. So it's going to be 1 squared minus 2 root 2 all squared, which is the same as, because we have 2 root 2I times minus 2 root 2I being squared, the I squared is minus 1, which makes it plus 2 root 2 squared. This is plus 2 root 2 squared. So remember, this is u over v. So this works out to be 4 minus 8 root 2 plus 2I minus 4 root I squared. But I squared is minus 1. And so this works out to be, let's just make sure we didn't make any calculation error. 4 times 1 is 4. This is minus 8 times root 2I. This is plus 2I. This is minus 4 root 2I squared. So we didn't make any mistake. So it works out to be 4 plus 4 root 2. 4 plus 4 root 2. Then it's going to be plus I times 2 minus 8 root 2. 2 minus 8 root 2. So it's 2 minus 8 root 2. And that's divided by 1 square plus 2 root 2 square. 1 square plus 2 root 2 square, you put that in a calculator. Two root 2 square plus 1 square, that's 9. So that is u over v. So now I can square this now. I'm going to square this, and that will give me, not square it, raise it to the, well, actually this is actually a much longer method to do it. And so now this is what we get for u over v, and so now we need the modulus of the one u over v to the 5th. All right, the modulus of u over v to the 5th. So first we can find the modulus of u over v. So the modulus of u over v, to find the modulus of u over v, it's going to be equal to the square root of, it's the square root of a squared plus b squared. This is a, which is 4 plus 4 root 2 over 9. Square plus, this is now 2 minus 8 root 2 over 9, and then we're going to square that. So let me put that in my calculator. So we square this, we work out that now. 4 plus 4 root 2 divided by 9 square plus 2 minus 8 root 2 square divided by 9 square rooted. I'm getting 3.28. Just want to check again. 2 minus 8 root 2 divided by 9 square. So that's 1.07. And 4 plus 4 root 2 divided by 9 square. It's 1.15 plus 1.07. That's 2.22 square rooted. I get 1.5. So I get that. This is giving me 3 over 2. All right, so that's 3 over 2. And so what they want is, they want the modulus of u over v to the fifth power. So u over v to the fifth power is just going to be 3 over 2 to the fifth power. It's just going to be 3 over 2 to the fifth power. That's going to give us the modulus of u over v to the fifth. So if you want to simplify, you can. I won't. 3 over 2 to the fifth power. All right. Now they want the argument of u over v to the fifth power. Now the argument of u over v to the fifth power, you have to remember that the argument of z to the n is n arg z. So it's going to be equal to 5 times, it's going to be 5 times tan inverse of y over x. So it's 5 times tan inverse of, I'm going to just call this A, call this B, and call this A. So it's 5 times tan inverse B over A. You put those in a calculator. So let's work that out. 2 minus 8 root 2 divided by 9, that's B, divided by A, and A is 4 plus, so that's 4 plus 4 root 2 divided by 9. So I get minus 0.96, tan inverse of that is minus 0.76, and I add that to pi, 2.32 times 5, so I get 11.87. So this, I get that the argument is 11.87, and that takes care of this question. All right, that's the argument. All right, you have to remember you had to add pi to it. Let me not write it like this then. Let me write it as, this is equal to 5 times pi plus tan inverse of b over a, because it's in the second quadrant. Nice and easy, soft. Final part of this question now, we have that a function is defined by the parametric equation x equal 4 cos t and y equal 3 sin 2t. Determine the x coordinates of the stationary points. So if x is equal to 4 cos t, we can find dx dt, and dx dt is going to be equal to, when you differentiate cos, you get minus sine, so you get minus 4 sine t, that's dx dt. And then since you get dx dt, we need dy now by dt. Then dy by dt is going to be equal to, when you differentiate sine, you get cos. So that's going to be, you differentiate sine, you get cos, but the derivative of 2 sine 2t is 2 cos 2t. 2 times 3 is 6. And so we get 6 cos 2t. All right, that's dy dt. So now dy by dx is going to be equal to, remember dy by dx is dy by dt times dt dx. So dy by dt times dt dx. All right. So what does that mean for us? In our translation, dy by dx is going to be equal to 6 cosine 2t. So it's 6 cosine 2t divided by 4 sine t. All right. Now, at a stationary point, dy by dx is 0. So always tell them that. So at start point, at a stationary point, we know that dy by dx is equal to 0. So if dy by dx is equal to 0, then that implies that we're solving 6 cos 2t. We're solving 6 cos 2t equal to 0. If we're solving 6 cos 2t equal to 0, then that implies that the cos of 2t is equal to 0. And then if the cos of 2t is equal to 0, then what do? We draw our circle. We know that cos is positive in the first and the fourth quadrant. The cos is positive in the first and the fourth quadrant. And cos inverse of 0 is, cos inverse of 0 is pi by 2. So in the first quadrant answer will be pi by 2. And in the fourth quadrant it's 2 pi minus pi by 2, which is 7 pi by 2. All right. All right, 7 pi by 2, is that right? 2 pi minus pi, 2 pi minus pi by 2, that's 4.71. 7 pi divided by 2. Let me write it better. I don't think this says 7 pi by 2. It's 2 pi minus pi by 2. Let me write that better. 2 pi minus pi by 2. And 2 pi minus pi by 2 is, that's 4 pi over 2. This is 3 pi by 2. 3 pi by 2. All right, that's better. It's not 7 pi by 2, it's 3 pi by 2. And so then that implies that t, or 2t rather, because this is 2t, is telling us that 2t is equal to pi by 2, or 2t is equal to 3 pi by 2. That's what we get here. All right. So now we can divide through by 2. And if we divide through by 2, we're going to divide through by 2. And when we divide through by 2, what we're getting is t is equal to pi by 4. And then we're getting that we divide through by 2 over here, and we're going to get that t is equal to 3 pi by 4. All right, now that we get t is pi by 4 and 3 pi by 4, now we can find the x values of the stationary point. All you have to do is plug in t as pi by 4 into x. And so we go back up here and put 4 cos t. So 4 cos pi by 4. The cos of pi by 4 is, root 2 over 2. And so x is going to be 4 times root 2 over 2. That's one stationary point. And another point is going to be put in 3 pi by 4. 3 pi by 4. 4 cos that is the cos of 3 pi divided by 4. That's minus 4 root 2 over 2. So that's minus 4 root 2 over 2. So those are the two x values of the stationary point. Nice and easy, soft. That takes care of question number 1. Nice and easy, soft. All right. Now that we finished question 1, now this kickstarts question number 2. Looking at question number 2, it says a function w is defined as wxy is equal to ln 2x minus ln 2x plus y over x minus 10. Find dw by dx. Dou w by dou x. So we're doing partial derivative, we're differentiating the function with respect to x. So for me, I'm going to rewrite w as ln the modulus of, I'm just going to separate it so it's easier for me to differentiate. I'm separating it as the modulus of 2x plus y, and it's being divided by, so it's minus ln x minus 10. This way it's easier for me, nice and easy. Now I can differentiate with respect to x easier. So dou w by dou x is going to be equal to, when I differentiate ln, it's going to be 1 over 2x plus y times 2. So it's 1 over 2x plus y times 2. I put a 2 in the numerator. Minus, this can be now minus, when I differentiate x minus 10, it's going to be 1 over x minus 10. All right, nice and easy, soft. That takes care of this question. That's dw by dou x. Now, if you wanted to put it at as one fraction, you could. Maybe you prefer to see it as one fraction. So you could write it as 2 into x minus 10 minus 2x minus y over 2x plus y times x minus 10. This is just to simplify it. If you want, I wouldn't. That's a waste of time. But if you want, you can simplify it. And then in reality, that works out to be minus 20 minus y over 2x plus y times x minus 10. Nice and easy, soft. That's what we would get. All right, that would be dw or dou w by dou x. All right, now the next question says integrate e to the 2x sine ex dx. Now first thing I notice, I have a e to the 2x here, and I have a e to the 2x and a e to the x. And so to do this integral, what I'm going to do, I like to call the integral I. So let I be equal to, I like to call it I. I is the integral of, I'm going to rewrite e to the 2x as e to the x. This is really e to the x square. This is e to the x square times the sine of, it's like the sine of e to the x dx. Sine of e to the x dx. Now, if I were to do a u substitution, right, I'm going to let, well, I don't want to use u since I might do by parts afterwards. I'm going to let r. I'm going to let r stand for e to the x. I'm going to call it r. R is e to the x. And so if r to the e to the x, then dr is going to be equal to e to the x dx. So what does that mean? That means that this integral I works out now to be equal to this e to the x all square can be written as e to the x times e to the x. That's what e to the x square mean, e to the x times e to the x. Now, this e to the x, this e to the x dx is going to be dr, and then r is going to be e to the x. So where I have e to the x here and here, that becomes r. So this is going to be working out to be the integral of e to the x is r, e to the x dx is dr, sine, so it's r sine r dr. That's what I'm integrating. All right, so let's do that. Now to do this, we're going to use integration by parts now. So now we're going to let, then you have to think of ILATE rule, ILATE, and you know that algebra comes before trig, using ILATE rule. And so using ILATE rule, we're calling u as r, u is r, and so du is going to be, when you differentiate r, you're getting 1. And then we're calling dv sine r, and so if dv is sine r, when you integrate sine, you get cos, and so v is cosine r, v is just cosine r, and so I is working out to be equal to u times the v, which is r cos r, minus the integral of v du. But the integral of v du, when you integrate cos r, you just get sine r. So it's r cos r minus sine r plus some constant c. And the question finish. Well, not entirely. We have to substitute back for r. Remember, r was e to the x. So the final answer is e to the x cosine, e to the x cosine e to the x minus the sine of e to the x plus c. Nice and easy, soft. So that's how we get this. Nice and easy, soft. All right. Next part of the question, it says let f of x be equal to x squared plus 2x plus 3 over x minus 1 times x squared plus 1, where x is between 2 and 5. It says use trapezium rule with 3 equal intervals to estimate the area bounded by f between the lines y equals 0, x equals 2, and x being 5. So pretty much we're integrating f of x from 2 to 5. So this is what we're finding. We're finding the integral from 2 to 5 of f of x. That's what we're finding, but we're going to be using trapezium rule. Using trapezium rule, the integral from 2 to 5 of f of x, trapezium rule, it's going to be h over 2 into y naught, where y naught is the last y value, y naught plus yn plus 2 times the other y values, plus 2 times your y1, da 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 da. So that's the formula that we use for trapezium rule. So let's go ahead and do this using trapezium rule. What I like to do first is, of course, work out h. H is going to be b minus a, which is 5 minus 2, which is 3, over n. N is 3, so h is 3 over 3, which is 1. So next thing I like to do is create my table. I like to create my table. my table just gives me my values of x and y for the different ordinates. This is x, and this is my y values. When x is, I need to go from, that's going to be from 2, then I go 3, then I go 4, then I go 5. All right, that's what I need to do. Plug in 2. When x is 2, what would I get up here? 2 squared plus 2 times 2 plus 3, that's 11, divided by 2 minus 1 times 2 squared plus 1, and 2 squared is 4, 4 plus 1 is 5. So right here I'm getting y as 2.2. That's for when x is 2. When x is 3, what will I get? I'll get 3 squared plus 2 times 3 plus 3, which is 18, divided by, that's 3 minus 1, times 3 squared is 9 plus 1 is 10. I get 0.9. Then I put in 4. I get 4 squared plus 2 times 4 plus 3 is 27, divided by 3 times 7, 4 squared is 16 plus 1 is 17. I get 0.53. I get 0.53. Then I plug in 5, and I'm getting 5 squared plus 2 times 5 plus 3 is 38, divided by 4 times 26, and I get 0.365. 0.37. And so using trapezium rule to evaluate the area is going to be equal to h over 2. H is 1, so it's 1 over 2 into y naught. Y naught is the first y value of 2.2 plus yn, which is plus 0.37, plus 2 times 0.9 plus 0.53. So 0.9 plus 0.53. So when I work this out, that will give me the area. So working this out, I'm going to get, let's put all of this in our calculator. 2.2 plus 0.37 plus 2 times 0.9 plus 0.53 divided by 2, and I get 2.72. So that's the area. I get 2.72. That's what I'm getting using trapezium rule. Nice. Now it says, using partial fraction, show that f of x is 3 over x minus 1 minus 2x over x squared plus 1. So we need to separate it using partial fractions. Let's look back what f of x was. F of x is x squared plus 2x plus 3. So we have x squared plus 2x plus 3. That's being divided by x minus 1 times x squared plus 1. So now we're doing this division now. And so what we're going to get is, this is going to be, well, it's going to be a constant a over x minus 1. So it's a constant a over x minus 1 plus, it's going to be bx plus c over x squared plus 1. So now all you have to do is find the common LCM. The common LCM is going to be, of course, x minus 1 times x squared plus 1. And so this into this leaves x squared plus 1, so it's going to be a times x squared plus 1, which is ax squared plus a. And then this into this leaves x minus 1, so it's going to be bx plus c times x minus 1. And remember, it's equal to this. All right. So now, whenever the denominators are the same, we can just equate their numerators. So this implies that equating their numerators, what they're basically saying then is x squared plus 2x plus 3, x squared plus 2x plus 3 is equal to ax squared plus a. Now bx times x is bx squared, so it becomes plus bx squared. Bx squared, now bx times minus 1 is minus bx. Then c times x is plus cx. Then c times minus 1 is minus c. And so that's what we have. So all we have to do now is equate coefficients. Equating coefficients, we have x squared, and we have ax squared and bx squared here. So what that is telling us is 1 is equal to a plus b. Equating x terms, we say 2x. 2x is equal to minus bx plus cx. So we can write it as 2 is equal to minus b plus c. And then we have 3 is equal to a minus c. A minus c. All right, nice and easy. From the first and the third equation, I'm going to subtract them. Equation 3 minus equation 1, that will give me 3 minus 1 is 2. A minus a gone, and so I left back with minus c minus b. So 2 is equal to minus c minus b. But I also have 2 is equal to minus b plus c. Nice. So that means if I add these two equations, what's going to happen? 2 plus 2 is 4. And so 4 is equal to minus c plus minus c gone. And so 4 is equal to minus 2b. And so if 4 is equal to minus 2b, then that means that b is equal to negative 2. If b is equal to negative 2, I can substitute b being negative 2 in the first equation. And so that means if I have negative 2 here, I can bring over negative 2 to get positive 3. And so if b is negative 2, then a is 3. If a is 3, then that means 3 minus c is 3. And so c must be 0. So c must be 0. So what does all that mean? That means that in conclusion, if you replace this now with a is just 3. I'm going to replace a up here now. A is just 3. A is 3. All right, nice. B is now -2 and C is 0. So we can replace those and say C is of course now 0, B is -2. Now if B is -2, instead of putting -2x in the numerator, the plus and a minus just give you a minus anyway. So we can just replace this plus right here with a minus. And then we can just ignore the +0. The +0 doesn't change anything. So that's what we do to show that. All right, so that's done. So write shown. All right, or you can write proving. That takes care of that. It says, hence, evaluate the integral from 2 to 5 of f of x. Since it says hence, instead of using this, we're going to use this. All right. So what we're then going to say is, since it says hence, we're going to say, so the integral from 2 to 5 of f of x dx, integral from 2 to 5 of f of x dx, that's going to be equal to, using the hence, it's going to be the integral from 2 to 5 of, the integral from 2 to 5 of 3 over x minus 1 minus the integral from 2 to 5 of 2x over x squared plus 1. Now I left off my dx, but don't ever do that. Now integrating this, you're going to get integral of 3 over ln x minus 1. If you factor out the 3, you're going to get 3 times ln of x minus 1. So it's 3 times ln x minus 1. And you're integrating that from 2 to 5. Minus, now the integral of this, the differential of x squared is 2x. And so it's just going to be minus ln x squared plus 1 from 2 to 5. Integrating that from 2 to 5. So now we're just going to plug in those now. So it's going to be 3 times, plugging in 5, it's going to be ln 4, 3 times ln 4 minus ln 1, and ln 1 is 0, so it's 3 ln 4 minus, plugging in this now, we're going to get 5 squared plus 1 is 26, so that's ln 26 minus ln 5. Put all of this in a calculator. 3 ln 4 is just ln 4 cube. You put in a calculator ln 4 cube minus ln 26 plus ln 5. Nice and easy, soft. So you work this out and you're going to get ln 4 cube, 4 cube. So ln 4 cube, which is 64, minus ln 26 plus ln 5, that's 2.51. Nice and easy, soft. That takes care of question 2, and now we will go to module 2. Nice. 3. Question 3 is